Good evening, everyone. I am Usman K, Assistant Professor, BITM Ballari. First, I welcome you all to my second video lecture on Module 5. So, in the previous video lecture, we discussed about what is flat surface and what is curved surface. So, in first four modules, we discussed how we can create flat surfaces like a polygons. But in case of fifth model, we would like to discuss how we can create curved surfaces, because every three-dimensional object or any three-dimensional images contains plane surfaces as well as curved surfaces. So we also discussed various types of curved surfaces, how to create curved surfaces, and what is the definition of curve. So the simple definition of curve is it is a collection of points where each point contains neighbors, but except first and last point does not contains neighbor pixels or neighbor points. So we discussed like one of the type of curve called Bezier curve. So in that Bezier curve, we discussed various types of Bezier curves. Now today, I would like to continue how we can solve various types of problems on Bezier curve. So after solving problems, then I will demonstrate or I will trace one of the lab program called using animation. We need to create one flag. So this is the problem statement. Now I would like to explain. So assume that one of the problem is given based on the Bezier curve concept. We would like to solve the problem. So the simple definition of Bezier curve we learned. Bezier curve can be generated with the help of control points and some of the tangents. Now we also discussed Bezier curve equation. So whenever we want to create any curve, first we need to decide how many pixels are there in that curve. So after deciding how many pixels are there in that curve, we need to decide what is the each and every pixel position in that particular curve like this. So as we discussed in the previous class, assume that we have a one curve here. I want to generate one curve between P0 to P1. So if I want to generate one curve between P0 to P1, P0 to P1, I need to go on determine what is the pixel position from P0 to P1 by substituting U value from 0 to 1. And I also discussed here we are using parametric equation to create or to construct a curve like this. Now this is nothing but Bezier curve equation where P of u is called position vector, and sigma k equal to 0 to n. Now P of k is nothing but number of control points, and B is k n called basis function of u. So this is the equation number 1. Now Bezier polynomial, or I can say that Bezier blending function can be given as c of n comma k u power k into 1 minus u power n minus k. So this is the equation for the uh, blending function, and c of n k is nothing but it is a binomial coefficient. So now we need to determine coordinate position with respect to x-axis, with respect to y-axis, and with respect to z-axis. So these are the equations we supposed to remember whenever we are solving any type of problems on Bezier curve. So let us begin with one problem on Bezier curve. So the question is, or the problem statement is like this: construct the Bezier curve for the following control points. So control points are given. First control point is 4, 2. Second control point is 8, 8. Third control point is 16, 4. So now this is the problem statement is given. For this problem statement, we need to create one curve. So if I want to create Bezier curve with the help of these control points, then first I would like to write what is the given. So given is there are three control points are given: P naught, X naught, Y naught, P1 of X1, Y1, P2 of X2, Y2, where P naught equal to that is 4, 2 means X naught is 4, Y naught is 2. This is our first control point. Second control point is P1 of X1, Y1, that is P1 of 8, 8, where X1 is 8, Y1 is 8. Similarly, third control point is given P2 of X2, Y2, where X2 is 16, Y2 is 4. So these are the three control points are given. So with the help of these three control points, we need to determine each pixel position between the first control point to last control point. Then the Bezier curve equation is P of u equal to k of 0 to sigma n p k into blending function k comma n of u. Here our number of control points are 3. Then I will write here equation k equal to 0 to 2, where k value starts from 0. Then I can say that k equal to 0, k equal to 1, k equal to 2. So there are three control points are there. Then I will start substituting k value 0, and next is 1, next is 2. Assume this is equation number 1. To solve this particular problem, we are supposed to calculate three things. So first one is we need to determine position vector P of u for three control points. Then substitute ke value is equal to 0, 1, 2 in equation number 1. Then you will get position vector P of u. So I substituted P naught here, k value is 0, then it becomes P0. P0 blending function 0, 2, here k value is 0, n value is 2. Next of u plus here I am substituting P1 blending function k comma n means k value is incremented by 1 and n value is constant, that is 2 of u, plus p value is incremented by 1, p becomes 2, blending function 2 comma 2 of u. So this is equation number 2. So first we need to determine position vector p of u. Then we need to represent each control point P0, P1, P2 in terms of x and y coordinates. Then we need to use this equation. See that here, here we need to use these particular equations, x of u, y of u. So by using these equations, I would like to calculate, or I want to represent each control point P0, P1, P2 in terms of x and y coordinate. So what I will do means, wherever P naught, P1, P2 is there, I will write x naught, x1, x2. Then this equation will become determining coordinate position of each pixel with respect to x-axis. Next equation, wherever P value is there, P naught, P1, P2 is there in the previous equation, in this equation. Now what I will do means, I will substitute y value. Wherever P naught is there in the previous equation number 2, in the equation number 2, I will replace that P naught values to y value. Then I will get coordinate position of each pixel in that curve with respect to y-axis. So this is equation number 3. So this is equation number 3. We represented each control point in terms of x and y coordinate. So if you see x-axis, we have x0, x1, x2. Because our control points are 3, those control points k value ranges from 0 to 2. Then I return x0, x1, x2. So this is equation number 3. So third, we need to calculate blending function. If you see this equation number 1 here, if you see equation number 2, here also we need to calculate blending function Bz for 0, 2, next for 1, 2, for next 2, 2. If you see equation number 3, in this equation number 3 also we supposed to calculate blending function Bz 0, 2, 1, 2, 2, 2. Then here I written clearly heading calculate blending function for 3 control points. Then the equation to calculate blending function or basis function is Bez k comma n equal to C of n comma k into u power k into 1 minus u power n minus k, or I modified this formula into nck. That is, we need to calculate here binomial coefficient. nc c of nk is there, I written that is nck. That is nothing but we are calculating binomial coefficient value ncr for this equation. But remaining I written as it is, u power k into 1 minus u power n minus k. So I will assume this is equation number 4. Then by seeing equation number 3, I supposed to calculate blending function for 0, 2, 1, 2, 2, 2 by using this particular formula. Next, I will calculate blending function for 0, 2, that is substitute k value 0 and n value 2 in equation number 4. Then you will get basis function for 0, 2. So I written n value 2, c value 0, u power 0 into 1 minus u power 2 minus 0. After evaluating this equation, I will get blending function for 0, 2 is 1 minus u square. This is basis function for 0, 2. Similarly, substitute k value 1, n value 2 in equation number 4. Then after substituting k value 1 and n value 2 in equation number 4, I calculated blending function for 1, 2, that is 2 into u into 1 minus u. So this is blending function for 1, 2. Similarly, I want to calculate basis function or blending function for k equal to 2 and n equal to 2. That is blending function b is at 2 comma 2 of u. Here I substituted k equal to 2, n equal to 2 in equation number 4. After substituting k and n value in equation number 4, I got this is the equation u square. So the blending function for 2 comma 2 is u square. So I will repeat. I calculated basis function or blending function for 0 comma 2, for 1 comma 2, for 2 comma 2. Now after calculating blending function, now I would like to substitute these values in equation number 3. Try to see the equation number 3. This is the equation number 3. So in equation number 3, what we did, we represented each control points in terms of x and y coordinate. So now what we did is we calculated blending function 0 comma 2, 1 comma 2 and 2 comma 2. Now whatever the values you calculated, now you substitute those blending function value in this equation. So these values, after substituting these values in equation number 3, then I will get new equation for the equation number 3, that is x of u and y of u is like this. So what I did here, this is a blending function 0 comma 2 is there. 0 comma 2 is nothing but 1 minus u square. This is 2u. This is blending function 1 comma 2. I replaced that blending function 1 comma 2 to new equation called 2u into 1 minus u. Similarly, blending function 2 comma 2, I replaced that to u square. Then we are using, these are the two equation x of u and y of u to calculate each pixel position from the first control point to last control point. Then what I will do means here, after calculating this, I substituted this value. After substituting this value, now I would like to substitute x0, x1, x2 value, y0, y1, y2 value. We know that in the problem statement only it is given 3 control points value, that is p0 of x0, y0, p1 of x1, y1, p2 of x2, y2. Now I will substitute these values in this particular equation. So after substituting the x0, x1, x2, y0, y1, y2 value in this equation, then I will get a new equation for x of u. The new equation for x of u is, after solving this, after evaluating entire this expression, final result I am explaining, I got x of u equal to 4u square plus 8u plus 4. This is the equation we are using to calculate what is the pixel position along that curve from the first control point to last control point with respect to x-axis. Similarly, we want to substitute a y0, y1, y2 value in this equation. See the mouse pointer in this equation. After substituting y0, y1, y2 value in this equation, then I solved this equation. After solving this equation or after evaluating this particular equation, I got y of u is minus 10u square plus 12u plus 2. So this is the equation we are using to calculate what is the each pixel position along that curve from first control point to last control point with respect to y-axis. Now with the help of these two equations, that is x of u and y of u, now I will go on substitute u value from 0 to 1.0. Now please you see that I created one table. The table contains three columns. First column u value, second column x of u value, third column y of u value. Let us start substituting u value 0. When you substitute u value 0 in these two equation, this is the equation. If you substitute u value 0 in this equation, you will get x of u equal to 4. I written x of u equal to 4 here. If I substitute u value equal to 0 in this equation, see the mouse pointer, then I will get y of u equal to 2. Means first pixel position is 4 comma 2. Please you see the mouse pointer. Please you see the mouse pointer. First control point or first pixel position I got 4 comma 2. First pixel position when I substituted u value equal to 0. Next I will substitute u value is 0.1. After substituting u value 0.1 in this equation as well as in this particular equation, again I will get second pixel position along this curve. Like this. I substituted u value 0.2. I got 5.7 x of u value. Y of u value got 4. Means x axis value I got 5.7. Y axis value I got 4 for the third pixel. So like this, I substituted u value from 0 to 1.0. So when I substituted u value 1.0 in the two equation x of u and y of u, see the last control point values I got 16 and 4. So I can say that 16 comma 4 is the last control point position or last pixel position in that particular curve. So this is the problem today I solved using Bezier curve like this. Now you can see that here u value ranges from 0 to 1.0. So if u equal to 0, that is called starting point. When u becomes 1.0, that is called ending point. So between starting control point to ending control point, you can take n number of control points. N number of control points. So if you take n number of control points, you will get different shape of the curve like this. So this is a problem we solved today. Now I would like to explain what are the properties of Bezier curve. So the first property of the Bezier curve is Bezier curve mainly depends on the number of control points. As I said in the previous slide, if n control points are there, you will get one Bezier curve and that is one shape, one particular shape. If your Bezier curve contains n minus 1 control point, you will get one more curve with a different shape. So like this, if you take this a Bezier curve, in this Bezier curve we have three control points like P0, P1, P2, and we have a number of control points minus one tangents. So here P0 to P1 is a one tangent, P1 to P2 is a one more tangent. So with the help of these tangents and control points, I created one curve. So I can assume that our curve crosses from first control point to the last control point, but it's never crossing from the one of the control point called P1. So what I want to conclude here means Bezier curve depends on the number of control points in that particular curve. Based on the number of control points only, we are creating particular curve like this. And here we are assuming P of 0 is nothing but first control point P of 1 is nothing but last control point, and our U value ranges from 0 to 1. That U is called parametric constant. This is the first property of Bezier curve. So the second property of the Bezier curve says that slope of the control point can be calculated as follows. Means the whenever we are creating any curve, we are supposed to calculate what is the slope of that particular curve. So the slope of the first two control points can be calculated as follows. We are using, these are the equations. We are using p dash of 0, that is equal to minus n into p naught plus n p1, p dash of 1 equal to minus n p of n minus 1 plus n into p naught. This is called first derivative of Bezier curve. This is called first derivative of Bezier curve. The slope of the last control point. This is the slope of the first control point. Slope of the last control point can be calculated using the following formula. So this formula is called second derivative of Bezier curve. So what I would like to explain is, here we have two properties I written. Two properties I written with respect to Bezier curve. So in the next video lecture, I would like to explain lab program. So before explaining lab program, you supposed to solve this particular problem. So if you understood how exactly we are using Bezier curve equation to create or to generate the Bezier curve, then you can easily understand that particular lab program. Thank you.